Well, hello, welcome to our webinar. We're excited to have you here with us today with APICS and ASCM Inland Empire Chapter. And we are going to be speaking today with John Andresen, who is going to talk about emerging with supply chain strength using RFID. These days with not only the post-pandemic, but also all the other world events going on, clients are definitely starting to climb up that technology curve in order to be successful. So this is one of many, actually, concepts that's out there in the technology space that could be well worth considering. So we're excited to have a true expert with us today to talk about it. And so John is president of Technology Solutions, LLC in Ventura, California. He's a business and technology consultant working with integrated systems design, RFID expert with an emphasis in the aviation sector. He has a lot of background in aviation. He's also an e-business expert, and he also has ATA Spec 2000 expertise. And last but not least, he has an MSME from MIT. So we're thrilled to have John with us today. Now, before we get started, we would encourage questions. Please put them in the chat box or the Q&A, and I will feed them to John and at good increments. You know, we always love, from an APICS Inland Empire standpoint, we always love your feedback on what other topics you'd like to hear about for our future webinars. So I just throw that out there as well. All right, with that said, John, we'll turn it over to you.
Okay, thank you, Lisa. It's great to be here and just kind of share my passion about RFID is one of the passions, but as we get into the presentation, you'll realize it's really about the data and how important good data is. So some people may not even be sure exactly what RFID technology is. So I thought I would describe that to begin with so that they, if they really don't want to know about this, they can drop off now. RFID stands for radio frequency identification. The technology is very similar to barcodes in terms of labels on parts. We put RFID tags on parts, but RFID is better in so many ways. You don't have to see each label. You don't have to be able to touch each label like with a barcode so that you can shoot it with a scanner. RFID can read at least 300 labels per second. So you can read a lot of data in a short amount of time. And then it allows other business processes like transparent data collection, where you can automatically collect data if an RFID tagged part walks by or box goes by. You can automatically gather that data, and that's not typically possible with barcode technology unless you're on a production line environment and you've got a luggage tag or something. But RFID is just one of the many auto ID technologies that also include 1D and 2D barcodes, and we'll discuss the difference in those later on. Optical character recognition, Bluetooth tags, GPS tags, and other technologies as well. That I mean, even facial scans and retina scans would fall into this category of automatic identification and data capture. So my background is got a little education. I've had 2 institutional careers at Southern Pacific Railroad and United Airlines. And then I've been consulting for the last 20 plus years in those areas of business process improvement, technology integration. So some of the customers that I still serve. But when I start, people want to know, well, who am I really? Well, for decades, actually, I was known as the barcode guy because I had written the standards in aviation and in railroad industries for the barcode spec. But you know what? I'm not the barcode guy. And then as we moved on into RFID technology, they were calling me the RFID guy in aviation. And you know what? I'm not the RFID guy either. I'm really the data guy. I'm concerned about getting good data, fast, accurate data into our computer systems. We really live in a unique time, depending upon how old you are. I'm probably older than most of you, but I've been part of this group that has moved the world from analog data to digital data. We've made that transition over the last 30 or 40 years to where now we're absolutely dependent on the digital data that we get, but we need to make sure we have good digital data. So it's all about the data. That's really what's important. Good data prevents mistakes from happening. It provides efficient operations. It provides accurate planning. It provides a historical analysis. When you want to know, well, what happened 6 months ago, that data is still in your systems, and you can review and analyze it and make better plans because you have that data. And it's in digital form. It's not on a sheet of paper somewhere where it would just be impossible time-wise to analyze that data. And the data lasts a very long time. And that's the good data and the bad data. It all lasts a very long time. And so you want to make sure that you're gathering good data and not creating and saving bad data. So my company philosophy has been for decades that success comes from this combination of hardware, software, and peopleware. Now, everybody knows what hardware and software is, but what's the peopleware? And the success you see in the middle of that triangle is good data. That's where the good data comes from. But peopleware, what's that? Well, peopleware is the foundation. You can have the hardware and the best hardware and software in the world, but if your peopleware isn't in place, then the rest of the system collapses. And what is peopleware? Let me flesh that out a little bit more. Peopleware is everything that's not the hardware and the software. And that includes good business process, bad business process, training or lack thereof, understanding of the business process, the money allocation, the manpower allocation, the relationships between companies, or even in your company between departments. I've seen many departments that don't, have no interest in helping that other department do their job well. And so it ends up with the peopleware problem. And the hardware and software won't solve that. You have to focus on the peopleware and make sure that the peopleware is an integrated part of the system that you're putting together. And then, of course, the changing priorities and resource constraints. And those have been, are very dynamic and are impacting just about everything we do these days because so many things are changing. The other concept I want to introduce you to is the fact that there are, in fact, two parallel supply chains. We all know about the physical supply chain. You issue a PO, the manufacturer builds it, they put it on a truck and ship it to you. It's transferred to a train. That loop may happen several times. If it's coming from a foreign country, it ends up here. And so the same process of shipping and transferring until it finally gets delivered to you. And that's the supply chain that we all know and understand. But I'd suggest that the other supply chain is the data supply chain. It's the same, it parallels the physical supply chain, but it's the data that comes from the purchase order, the manufacturing process, when it gets shipped, how it gets shipped, where it gets shipped, all the way through to delivery. In pre-COVID times, these things were better in sync. And as a culture and an industry, we've been working on this for better than 20 years. Certainly this all came about with the advent of the internet and the digital data communications that are now in place and we take for granted. But I have a personal experience every day that these data chain processes are chaotic and disjointed. I order parts from a distributor who orders them from a manufacturer, and the manufacturer orders them from a company in China, and they can't tell us within months when those items are going to show up. They'll just to cover their rear ends, they'll say, well, it'll be about 4 or 5 months. And sometimes it's 4 or 5 months, and other times it's 2 months. They have no idea, obviously. It's sitting on a ship outside Long Beach Harbor somewhere, and they have no idea, which ship it's on, what order that ship is going to get unloaded, and when it gets unloaded, when it's going to get on a truck or a train and get out of Long Beach. But we need to get the data chain working better. So the physical chain is fine, but the data chain, if we start to do a better process with that, then we can make plans and for our customers and our own operations. Well, how do we do that? What problems are we facing? Well, there's certainly a labor shortage. Wall Street Journal was reporting about 2 job openings for everyone looking for a job earlier this week. 2 job openings for everyone. So if you're having a hard time finding people, much less good people, that's the reason. There's not enough good people out there, and there's a lot of openings. Everybody's looking for good people, so there's stiff competition. And I know Lisa's talked about that in many of her other presentations. Then we get to things like lack of skills and the training required to bring that skill level up. We're facing a huge backlog of work to handle. And the consumer demand will be high for years. People have a lot of money to spend. So even today, I read in the journal that consumer demand was up, and the economy, the U.S. economy is up. So the demand will continue, and we need to figure out a way to operate more efficiently and get ahead of it. Long Beach, I understand, and Lisa, correct me if I'm wrong, but Long Beach is now operating 24/7.
They're working towards it.
Okay, and it's, again, there's a peopleware problem. There's a lot of coordination that has to happen. It's not just one entity who can make a decision about this. There's a lot of other industries, truckers and trains, and that all have to agree on how this is going to work. But that's all causing other shortages are still in place. The trucking shortage and just the physical access to the beach, to Long Beach, and storing all the containers that are offloaded. That's why the ships are sitting off the coast here. But with the labor shortages that we're seeing, and where did I read that we have the lowest unemployment rate in 50 years, I think. I just read the other day. But these labor shortages will eventually bring in lower skilled workers into the industry. Wages will go up even for the low skilled workers, and that'll pull people in. But then you have the problem of those workers won't have the computer or even the keyboard skills for many years. And even reading, writing, and English speaking may be issues in terms of focusing on the peopleware problem here, to say we've got to make sure that the peopleware side of this is working well. But here's the place where technology can help solve some of these problems. And that's the hardware and the software side of that will mitigate a little bit some of the, if you expect people to write things on paper clearly so that somebody can copy them off paper into a computer correctly, that's where I'm going to address how technology will help.
Well, and John, you probably are going to address this, but Ed is asking, and this is kind of a big question, so maybe you'll address it as you go, but how do we fix the inefficiencies in our post-pandemic supply chain? Why is it taking so long for our data chains to both catch up and accurately reflect what's really happening? I mean, those are sort of loaded questions, but if you maybe you'll answer them as you go, or just prompt me if you want me to ask you that again later.
Okay. And let's hang on to that one till the end. I will address some of that. the supply chain issues touch so many different bases. It's like, how do you get, it's kind of a miracle that we're doing what we're doing, just getting physical parts, from China or Vietnam, manufactured is fine, but then all the transportation and the logistics of getting them delivered to us in the United States is kind of amazing by itself. But it's an evolving process. But what I'm going to be talking about is, it would help if we're all using the same digital standards in order to get the data supply chain beefed up more. Everybody can't be doing it whatever way makes sense to them. We have to coordinate this better. And we do that better coordination with digital data. And I will address that. So
I have some answers for you too, Ed, but we'll wait and see how it goes here. And I'll throw my 2 cents in.
So have you ever seen characters like this on one of your paper forms you're gathering, for parts coming in? So that's a 1, 5, oh, no, maybe that's an S. D, oh no, maybe it's an O. Could be a D. 6, G, or maybe it's G6. I don't know. What's your interpretation of that data? Can you imagine this is a problem in your company? Can you imagine what kinds of problems this causes? To not be able to understand. It's not like the characters are illegible, but they're not clear enough. So that's why we want to use automatic identification and data capture. The data, is not clear enough being handwritten. So we use AIDC to avoid errors. Errors follow the iceberg principle. You've probably heard this in other situations. If these are the errors you're seeing, the part that sticks above the water, this is how much more you're not seeing, and this will be very expensive for you. But if you find errors in your database, you're only seeing a few of the errors, but the other 90% of the errors are unseen, but they'll cause problems in all parts of your organization. The causes of the data entry errors are, you can imagine all these yourself. The high error rate of writing data on paper. People don't write clearly. And then the error rate of reading and typing data off forms. People can't understand what you've written. They just make typos. These are all just human traits. If I was doing this all day long, I'd make mistakes too. So we want to help the people not make mistakes. Even things like the data is on paper, but the paper doesn't get to the person who has to enter it into the computer in a timely fashion. And so there's just slow turnaround time on getting the data into the computer. And then all the other problems of unclear fields and the formatting, missing data. People don't know what to put right in that little box, so they just leave it blank. As well as then the lack of data quality, a quality check on the data. Does anybody check that that's the right kind of data, that they're writing the right number in the right box? Like, well, that's not a container number. That can't be a container number. It's too short. So is there any quality data check or data quality check being done? And certainly not if it's written on paper. But we can do that with digital data. So the benefits of RFID or barcode technology are this. Manual data entry, handwriting, hand typing. The time to enter the data is very long. The accuracy of the data is very low. With RFID and barcode data, the time to enter the data is very short. And the accuracy of the data is very high. It was more than 50 or 60 years ago, when electric typewriters were being introduced into offices, IBM did a study with touch typists, and they found that touch typists make an error once every 30 characters. Now, they usually know they made an error and they back up and they'll fix it. But they still made an error in their study. Every 30 characters, an error was made. So barcodes errors occur once every 3 million characters. 3 million. That right there is 100,000 times improvement in the accuracy of the data. 100,000 times improvement by just using barcode data. And RFID is way more accurate than that. So the question to ask yourself is, so how many touch typists do you hire in your production area? Do you hire touch typists in your production area? I bet not. Nobody can afford that. Yeah, they just expect people to be able to write correctly or to type correctly, but you don't hire touch typists. So you can guess how many errors are actually being made by normal people, by people like you and I, if we had to do that kind of job all day long. So there's a lot of errors being made here every day. You've probably seen this chart in other forms too. The prevention costs to prevent an error is, say, a 1x. If you find the error, to correct it is about 10x the cost. But if you don't catch it and your customer catches it, that failure cost is 100x. So it's just, there are orders of magnitude more expensive to not have good data at the beginning. So you want to put your efforts into preventing data mistakes at the beginning, and you'll save 10 or 100 times that amount later on by not, chasing down problems that were caused by bad data. So in a personal study I did decades ago, and it was my mistake. I was wondering, Jesus, it took me a long time to fix that. If it takes that long to make a mistake, it takes that long to find the mistake and then fix it. Now, finding a mistake sometimes can happen pretty fast. Somebody else looks at it and says, well, that's not right. And so good, okay. But if that's not right, what is the right number? I don't know the right number. I know that that's not right, but I don't know what the right number is. So how much time is that between making a mistake and finding and fixing the mistake? In this one study I did, it was 2,000 times. It took me 2,000 times. So if it took me 1 second to make a mistake, a typo, just a very human thing to do, I got distracted or I got my, sixes and nines mixed up, very simple thing. It took me 33.3 minutes to find the mistake, and I found that pretty quickly. But to find out what the right number was, took me 33 minutes. Now that's 33 man minutes. Women minutes, it's only 30 because they're better at this stuff than we are. But if you're a man, it's going to take you 33 minutes to fix a mistake. So some basic digital data principles I want to talk about here are put data into digital formats, barcode or RFID, on parts, on shipping labels, on warehouse shelves, on employee badges, on paperwork, on job cards. Don't print the data out if it has to be entered again. But if it has to be printed out, at least print it with barcodes so that somebody entering it later could just shoot the barcode and they'll get data that is 100,000 times more accurate than if you're asking somebody to type it back in again. Use intelligent data, and I'll talk about that in just a minute. Industry standard, common data, so that we're all using the same terms and know what the data means. And then collect data in digital form at the source. Data never gets any better than the source. It can only get worse. If somebody is copying down a number off a container or off a box, he's the only guy who knows that number, and then it goes into a computer system or on a paper form, and to find out what the correct number was is very expensive. So you want to collect digital data at the source. if at all possible. So what's this number? Maybe it's a shipment number or a serial number for the parts you're looking for, or it's a location number or an order number or a container number. Maybe it's a social security number without dashes. Who knows what that number is? Well, just that number, it's a naked number with no intelligence whatsoever. And if somebody wrote that number in the wrong box on your paper form, you'd be confused for a long time. You don't know what that data is. So how the aviation industry solved this problem was developed a standard called Spec 2000. Here's an example of an intelligent number. There's that same number again, 26326590. But we put some intelligence on the front end of that. Can you guess what that might be? SER. What if that's a serial number? The beauty of this is with tagged data like this, it's simple, it's plain text, it's WYSIWYG. What you see is what you get. It's easy for people to interpret, and it's easy for computers to interpret. Now, this was developed almost 4 years ago, before the internet age. But now we can put little brackets around that same data and call it XML data. And that's what all of our internet databases are made of, is XML data. XML data is intelligent data. It's tagged so that, and the beauty of this is both people and computers can make sense of this. So that if it's printed on a label, if it's printed on a barcode, you can use the barcode. But if your barcode reader doesn't work or somebody doesn't have one, people can say, oh, that's the serial number. So here's some examples of the kind of data that we have. Part numbers, PNR, serial numbers, manufacturing, data manufacturer, box numbers, NATO stock numbers, expiration date, unit of issue. All these are tags on the data, and we have hundreds more that are already defined. Now, this is what we use in the aviation industry. The logistics industry would develop a different set of data. But this is the beginning of, well, I'll get to that in just a second here. So here's some barcode examples. And this is more for people who aren't familiar with different kinds of barcodes and so forth. So there's different symbologies, code 39, code 128. You can see the code 128 has the same numbers, same data, but it's a lot shorter, so it takes up less real estate. And then you get to data matrix. Just for comparison, that same amount of data takes up a little tiny amount of space. But then we can put intelligent data in there, like in that in the middle of the screen is the you can see, and both people can see. If you don't have the technology, people can read it and make sense of it. Or if your barcode scanner reads that, it will pull out the data, and it has intelligent data. It knows the manufacturer's cage code, the serial number of the part it's reading, the part number of the part, the data manufacturer, and all that is gotten with a quick beep with a scanner. And you can read all that data in half a second. Whenever possible, we always use the human readable data and barcode data on every RFID tag. It allows each participant in the supply chain to use whatever level of technology they're capable of, because everybody's at a different state. Not everybody's going to buy RFID technology, and they're still eyeballing it. But even if they're eyeballing it and typing it in, they'll know which of those numbers is the part number on that box. So I think what the industry needs is visibility of data, of parts, of processes, simplicity, so that we can make sense. Humans can make sense of a lot of simple things, but when they get real complex, we give up, and we need experts then. You need experts to make it. So we need to keep it simple. And then we need the flexibility, and that's related to simplicity. but it allows us to change our business processes as the business needs change. So visibility, simplicity, and flexibility. How do we get that? Well, in the aviation industry, again, we have a whole architecture. This is a functional and data architecture. So that, but it's, I want to point out, you don't have to look at all of those other boxes, but the foundation of this architecture is Spec 2000 common data. So when we say part number, we know whose part number we're talking about. Is that my part number? Is that the OEM's part number? Is that the distributor's part number? Whose part number are we talking about? With an intelligent tag on that data, we will know which part number we're talking about. So let me get into RFID just a little bit. So this is an amazing technology. This, on my fingertip, is an RFID chip. They stick it in the middle of an RFID tag here, and the rest of this is just antenna. It's just the antenna to suck in the radio waves that are powering it. But that little chip, that little speck of pepper, converts radio waves to electrical power. It stores data. It handles communications with the reader. It handles error corrections with the reader. And it all happens very fast. So here's some examples. Retail industry for 20 years here has used these small tags, 96-bit tags. And it has just a unique number in the tag. And it's stored in a special part of the memory. There's 4 different parts of an RFID. In that little RFID chip, there's 4 different memory locations in there. Retail has always used the simplest, cheapest thing. They were trying to get down to a 5-cent tag. But there's tags with a larger memory, so you can put more data into it. So here's that picture again. This little chip has 512 bits, and that's about 80 characters, 80 ASCII characters of data that we can put in that. But they get very big too. We have 8 kilobyte tags and 512,000 bit tags. These are the size of dominoes. They're 1 inch by 2 inch. And the industry thought this was a great idea 15 years ago, but it got too complicated for the industry to implement. So we're focusing now on a 2 kilobit tag that allows us to put a birth record on the tag, as well as some other data beyond that. So, and then tags come in a variety of shapes. There's metal mount tags. You can see over on the left there, metal mount tags. There's tags you can embed in fabric for clothing, for your workers' clothes. If you launder those, you want to get them back to the right people, you can put an RFID tag in there. They come in long skinny forms, and down at the bottom is that heavy duty rubber one for a very industrial process. And then there's gum labels and plastic labels and so forth of all kinds. So they come in a wide variety of gum labels to these big rubber things to little checklists there in the middle that you can stick on parts. So a few factoids about RFID. How far away can it read? Well, on a passive tag, and these are all passive. There's other kinds of RFID that are the kinds you use at a hotel. Those are NFC tags, but you have to be within about 1 inch of the reader for that. So this is UHF RFID tags. They'll read 15 to 20 feet, but we've read them as far as 85 feet too. Tags, we can read at least 200 to 400 tags per second. So if you're doing a warehouse scan, you can walk in there and wave your gun around and read 200 to 400 tags per second. And it'll read a tag many times over so that you make sure that you get every tag. Do you have to see the tag to read it? No, you don't. It's activated by radio waves. And so the radio waves are transparent, and that's good thing and a bad thing, because you can't see where they go. And sometimes they go in places, they read things that you don't want them to read, but that's a whole other problem. So how are tags read? Well, with a fixed reader, these are these antennas up here that you would mount, say, on a portal or in a hallway or a doorway as parts come through or as boxes come through. Those fixed antennas would transparently, automatically read the RFID tag and know where that box is. Or you can also use a handheld scanner located in the lower right corner there. And those work with your smartphones, work with tablets, or there's more integrated readers that have communications and everything integrated in. But I think this is the wave of the future. With you use the smarts of your smartphone, and it handles the communication already. And can you read tags inside of a box where you can't see them? Absolutely. But limitations exist, because if there's other metal parts in there, you can't read through metal or liquid. So the liquid absorbs the RF signal. But you can read things inside of a box, and we do that all the time. So I'm going to talk a little bit about the aviation use cases, and I'll do this quickly because I want to get to the videos at the end here. We started using emergency equipment because of the safety and regulatory considerations. It took us a while to get going, but we branched out into asset tracking to track parts and wheels and tools beyond the emergency equipment. Emergency equipment is like life vests under the seats. Many companies are moving on into RFID tool tracking. And that is almost every aviation manufacturing industry needs tool tracking capability. But we're doing other things for adding intelligence to the whole process so that it'll inform you if something doesn't show up, and it should have. It informs you if something showed up in the wrong place. At least you know where it is now because of the transparent data collection that solutions we offer. And it's all based on business rules that you set. But you don't want to get sucked in by the technology. It looks like magic, but it's not. It's just physics. And we had our Delta customer 10 years ago was so excited with the success of RFID technology. The vice president said, well, we're going to tag 1 million things around here. And so he was too enthralled by the technology and didn't stick with the business process and the people work that he needed to.
We have another question, John, that might be appropriate right now. He's asking, how do you know you captured all of the tags in a geographic location? What if you had some no reads?
And that's where the business process is so important. If you don't know what you should be reading, RFID, it'll read tags multiple times. If I'm doing a test on my desk, it'll read a tag, 50 times in a couple seconds, the same tag. And so you have multiple chances to read. But if you don't know what is supposed to be there, you could miss something. RFID is probably much better for confirming that what is supposed to be there is actually there, because you don't know if you don't read something. And that is one of the downsides of RFID technology. But that's where the business process comes in. If you know what is being shipped to you, you can easily use RFID to confirm that all the things that are supposed to be in that box are in that box. But there's no magic there. That's why I said it's physics. You have to bolster it with a better business process to say, from that manufacturer or that shipper, I'm supposed to be getting these things. You can confirm that all those things are there. And then you'll find things like, well, wait a minute, I was supposed to get 5 boxes. I'm missing a whole box here. Where's that? And so it's better for confirmation than reading things. So in aviation, RFID is used for life vests under the seats. That was the big thing, you know, to check if a life vest is under a seat. It takes somebody, you know, a mechanic crawling around on his hands and knees for hours to determine that a life vest is under every seat. And periodically, they have to check that they haven't expired, because they expire after 5 years. They have to be pulled off the airplane, inflated again, make sure they hold air. Then they're put a new CO2 cartridge on that and wrap it back up again, and it's good for another 5 years. But we can track all kinds of parts, you know, life vests, medical kits, galley carts, portable oxygen bottles. And this used to take just hours and hours of time per airplane to check that everything that is supposed to be there is there, and that nothing's expired. And that's because we write the expiration date on the RFID tag. So we can read that instantaneously. So another problem aviation has is, well, I need a wheel for this A321 airplane, and I need a nose wheel, not the landing wheel. I just need the nose wheel. How long will it take you to find the right wheel? And when this is how they're stored? A long time. And there's no magic here, but I'll show you. Here's a video. And pardon my engineering approach to this. This is how engineers do marketing. We take a picture of what happens in the real world, okay? And it's not very classic. We don't edit it. So, but let me play the video here for you.
Right. It's when they move them. When you lose the problem. Yeah, Chris, I think on the little one over there, you read that one. Right. And the worst thing is, some of them maintenance are putting on cards, and then we just don't know where that card is. So at least this way we know we're looking only for an 88 main blanket. Is when they move them.
So sorry about that. It's going to play again here. This guy's reading 88 wheels scanned with RFID. He read them in 15 seconds. The old way of doing that, it would take him 2 hours, because he has to roll each of those wheels out of the way, write the number down, and then you know, do the same to the next wheel. And then he's got to roll them all back again. And you know, people keep thinking all this stuff happens like magic, and it doesn't. Somebody has to go out and do stuff, and it takes a long time. And in the case of rolling wheels around, it's dangerous. The big wheels weigh 400 pounds each. So if it gets away from you, you know, it can fall on you, or you hurt your back trying to catch it, things like that. But I want to show you another one. This is how I mentioned a mechanic checking life vests under seats on a wide body aircraft, doing it manually on his hands and knees, which he hates, by the way. This is idiot work. He doesn't like doing that. He wants to fix airplanes. But if they miss a life vest and they're caught by the FAA, it's $10,000 fine per flight segment. So the FAA says, well, how many flights has this plane taken since you can prove that that vest was under there? And that's where you get $1 million fines from the FAA. But with using RFID technology, so this guy is starting at the main entry door of the plane. He's going to wave at the cockpit with his handheld RFID reader, and then turn around and walk down the aisle, one aisle of a twin aisle aircraft, and read the life vests that are under flight attendant seats, in the cockpit, and all the other seats, and then 2 bags of spares that are in the back alley. But let me play the video. There's a way to the cockpit. Now, he knows what he's looking for. He knows what's supposed to be on the airplane, and he can confirm that all those things there, and you'll see the scroll bar on the little window there getting longer and longer as it crosses things off the list. And even before he gets around the corner, he's reading, 20 feet ahead of him of where he's walking. So there's the end result, and I'm sorry it didn't stick on the screen, but there's 254 vests he scanned in 35 seconds versus 4 hours of time. This is why the airlines have all moved in this direction. Anybody who can, has the bandwidth to implement a new project, it is such a tremendous benefit for them. And for the first time, they have data. Before, they would have to go out in 2 months and somebody crawl around the airplane again just to make sure that nothing's expired. And now we have digital data that nothing's going to expire. So they don't have to check the airplane anymore. It's a tremendous benefit. I didn't want to do that. There we go. So how does this relate to supply chain logistics? Well, we can put an RFID tag and track on parts in boxes, boxes on pallets, pallets on trucks, containers on a ship, a train, or a truck. And then we can send all the data ahead for tracking and planning for yourself, for your own operation, for your customers, for logistics people who need to know how much is they should be expecting. But gathering digital data at the get-go is the way that this all happens. This is where the business process is, though. If they don't know what to expect, that's what we want to do is in that data supply chain, we want to give them advance notice of what's heading at them and when it's heading at them, and they can track it all the way along the process. So lost shipments and data mistakes, is that costing your business money now? I bet it is, and it's costing you more than it was 2 years ago because things are confused and chaotic, and people who used to work there during COVID quit, got laid off. New workers, there's too much to do and not enough people to do it. But to use, I'd recommend using RFID to mitigate those costs and get a jump on your competitors to get your supply chains organized and get the data that you need to operate. So thank you for that. Just about made it in time here. So any questions or comments I can answer?
Yeah, actually, yeah. No, really interesting presentation. So I guess let's circle back to the question that we started with is how do we fix the inefficiencies in our post-pandemic supply chain? So certainly you've shown us some options here where you can use RFID to do something that could take 5 seconds that used to take, minutes in the past. Well, what are the main things you've seen in your work with clients as to why it's taking so long for folks to join this party as far as RFID goes? And, do they stop at barcodes and then decide that's enough, or what's happening there?
Often they do, and barcodes will often be enough. I don't recommend RFID for everybody because it's more complex and more expensive, and maybe barcodes are sufficient. But the key is the business process. And Lisa, this is your expertise. Let's look at the business process. What are we doing well and what aren't we doing well? What can be improved? And where are we making mistakes? So if we can focus on those areas, then we can add a little technology to it, barcode or RFID. And that will leverage the business process tremendously. But if your basic business process isn't clean and organized, then technology is just going to help you make mistakes faster. But
that is very true.
Yeah. You've got to have that business process analyzed and corrected as best you can. And then it keeps changing. I mean, different parameters keep changing and you've got to change with it. So I think you'll have a job for a long time, Lisa.
Well, I think that, there's certainly a lot going on, and you're absolutely right. It does come back to the business process. You've talked about some of them, but what would you say are you gave us some aerospace examples, which industries or product types, or where do you see most RFID providing the biggest return?
Certainly the biggest returns would be in a closed loop system. Logistics oftentimes is an open loop system. You don't have control over all the pieces from end to end. And so that makes it, but you need to find the advantage. What advantage could this offer to each of the participants along the supply chain and get them to buy in? Decades ago, Walmart tried to force them to buy in, and that didn't work so well.
Yeah, and they're talking about that again, because of the ports, the complications of the ports. There's new initiatives that have come out to try to get different parties to work together. It's quite the challenge, though, because there's so many conflicting objectives.
And moving freight faster is only one of the objectives. So,
yeah, that's true.
Tell me this doesn't get into the peopleware issues of.
We have another question here too. He said sorry if you missed it, but are there RFID read issues with the RFID tags being close to metal?
Well, a gum label stuck on metal won't read. Because the metal absorbs the signal and doesn't give enough of the signal to the antenna on that gum label. And so, but it just needs a little insulation between that. I mean, you could kind of put think of a padded gum label on a metal part. Or what we use on tools and so many other things is like those little chiclets. It just needs a little bit of space off the metal, and then the tags will read fine. Now, they don't read as far as if it was on a cardboard box. They will always read less distance stuck to metal. So, but I mean, we can read 10 feet easily on metal, and that's in a tool room when we're taking inventory on tools. Generally, you can't stand at one end of a 30-foot tool room and, wave the gun at one end of an aisle and read everything.
Well, and a tool room example, it would seem like that would still, that wouldn't be a big deal. It would save you a ton of time.
Yeah, well, the other thing that it does, like in tool rooms, one of the big things, and this is probably more of an issue with aviation or medical, some tools have to be calibrated. And so, and if you use the tool and it's not calibrated, certainly these are in regulated industries. I guess that's a common denominator. In highly regulated industries, if you use a tool and it should have been calibrated before you used it, they, again, $1 million fines kick in a hurry. For aviation, they will ground the aircraft. They'll make it, you can't fly that plane again until you come back and check, because you measure the torque on that with an uncalibrated tool, and it gets very, very expensive to make those kinds of mistakes. So to be able to scan your tool room and say, oh, we got a tool over here that only has 2 days left, we've got to ship that out and get it calibrated, or not use it, pull it out of the stack so it doesn't get used, because we're going to be in real trouble if it is.
Yeah, very true. Well, who knew that we could have an interesting webinar for an hour on RFID alone? But actually, it brings up some really good ideas for us to consider. Now, not every business, not every product is an appropriate use of RFID. Of course, Barcode might be a plan B for those businesses, but it's certainly something that we should all be familiar with and looking at, and aware of when we should be looking at these types of technologies. There's all sorts of technology out there, and perhaps we'll have more deep dives into additional ones like 3D printing, that type of thing. So in the future, but thank you very much for your fascinating presentation, John. We really appreciate it. And I wanted to, before wrapping up, thank everyone for coming. I realized after I handed it off to John that I forgot to say who I was. I think almost everybody knows who I am, but I'm Lisa Andresen, and I'm president of Apex Inland Empire, as well as LMA Consulting Group. And we are going to be doing more of these webinars, and we're also going to work towards an in-person event later this year, as far as like an executive panel type event that we used to do. So some of you that have gone in the past, that we're going to work towards doing that again, as we can work that out with Harvey Mudd and others. And we also are starting we're going to start some classes for the public in the summer. So I'm going to posting those on the website shortly. So please keep that in aligned. It's the right time to look at training and providing education to your employees, or if you're or advancing your own education, because there's never been a more important time frame for manufacturing and for supply chain. I think, throughout history, there's a definite increase. There's going to be more jobs than we could imagine that aren't going to be able to be filled. And there's going to be a lot of technology they're going to be using. So I would highly recommend that you keep your education going and continue to attend these types of webinars. We also are going to, I'm probably going to put together a webinar next month on cybersecurity, because there's a lot going on. I was on a call earlier today, and it turns out that IT companies that have traditionally had like 1 or 2 issues a month are seeing a dramatic increase for businesses. So please pass that on to your leaders if you're not the person in charge. And if you are the person in charge, by all means, be concerned about this, because you have to get with the experts to figure out how you can protect yourself, because one business is just going to fold up shop because now they're starting to affect backup supplies too. So I throw that out there, and I'm going to see if we can get a speaker to talk about that next month or shortly thereafter. So thank you for joining us today. And thanks, John, for a fabulous presentation. If you have any other questions or follow-up items, feel free to send them on to us, and we appreciate you guys joining us. Thank you. Have a great weekend, everyone.